I just want to take stock. I know from mobility industry, some people are definitely taking care of transportation. Or anyone from the tech industry, tech industry? Right. So as soon as I mention the word tech industry, everyone assumes I'm talking about information technology, digital technology. And of course, technology is beyond digital technology. It encompasses biotechnology, energy technology, materials technology, manufacturing technology. So today, I do represent tech industry. It is not just digital. It's also manufacturing and materials, and that's the life sciences too. So we talk about this. As soon as I mention continuous flow manufacturing, I'm sure people are thinking something that happened over the last 100 years, and we'll give it a really different spin, and we'll see that evolving. Now, the topic is also about innovation, and I'm going to also talk to you about what is this breakthrough or quantum leap innovation all about. So we get started. I'm sure a lot of you might be thinking, with what is happening around the world, are we really evolving as humankind? You know, with the geopolitical situation and whatnot. And I've always, whenever I've spoken, and people would ask me, did we really come from the apes, like the chimp? Now, it turns out the chimp and humans, we have a common ancestor. Chimps are not becoming humans, and humans are not becoming chimp. So we just happen to be moving in a direction where, thanks to the fact that our brain mass, and this is measurable, capability of human intelligence that arises from change in brain volume. And you can see how different species of humankind were evolving over the years. And we're talking about a period of about 3 million years. But in the last 500,000 years, and particularly in the last 200,000 years, our brain volume really changed dramatically. And we are not the only intelligent animals, intelligent living things on this planet. Pretty much every living thing is intelligent. But we can always say we are one animal which is self-aware. So because of this brain volume, this neural net, we became aware. But the journey for us is to become conscious. In fact, to become universally conscious. And we believe as a society, as a civilization, that it is not now. We learned to be universally conscious 3, 4, 5,000 years ago. And that's the heritage we have. And that is why we feel so happy and so proud to be Indians. Because we come from such a profound heritage of being universally conscious. And all of this endowment happened because of the fact that our neural network grew over the last 200,000 years. And these 200,000 years have been really, really special. Compared to the previous 5 billion years on this planet, during this 200,000 years, profound changes happened. We start building something called shelter. And our first shelters were with just bones and whatever we could find as material. But since the last 10,000 years, which is after the end of the last ice age, which is called the Neolithic, the old Stone Age or the Paleolithic age was about using stones as just tools to shape the bones and the various other materials. But since the last 10,000 years, we actually build out of stone itself. It's called the Neolithic, and it still continues. We still build out of stones. But then we have been using more and more newer materials, and that's a question I asked this gentleman from Hero. What kind of materials are they researching on? And as you would know, that we have gone well past stone. We use a lot of metals, which is roughly 5,000 years ago. Metals with copper, metals with iron, or very recent. And India, as a profound heritage with metals. And if you see, we still have monuments lying with us. And this Ashoka pillar is 2,300 years ago, 3rd century BCE, still there for us to enjoy and see. This is an iron pillar which was created in a place in Madhya Pradesh called Vidisha, which was moved to the Qutub complex in Delhi, which was made 3rd century current era, which is 1,700 years ago. So we have had a terrific heritage in materials in this country, and we need to continue on this heritage. Now, having shown you how materials evolve, if you just go back 60 years ago at any part of the world, you would see constructions like this. This is central Tokyo, a really popular area called the Shibuya Crossing. And a picture taken in 1960 looks like this. And this is how Bangalore would have looked, Trivandrum would have looked, any part of the world would have looked. And although it is not simply iron and steel and masonry and cement, it is just about the same in the world. But look at this. Since the last 20 years, something just dramatically changed. The way we live, this entire event area looks completely different. It's so colorful. We can't imagine this 20 years ago. So materials really shape our world. And I'm going to spend a little bit time about how technology evolves to be in line with what we need to do today. So I would like you to imagine that in our progress as humankind, last 100 years have been extremely eventful, and we need to be able to visualize this. With this background, that we are evolving very, very rapidly, I would like you to imagine what a quantum leap innovation would be. We heard the term improvisation, and we use that term very often in our country. Now, I would imagine if K.J. Yesudas or a Balamurali Krishna were to improvise, that would be acceptable. They've trained for 40, 50 years. And on a particular stage, they might improvise a raga or a song. But a college kid improvising, and improvising would mean using the wrong tool or the wrong method. We can't simply improvise, but still, localization or something like that, application would involve some improvisation. So improvisation is never going to lead us to a quantum leap situation. But improvements can, SpaceX is simply improving on technologies that are available in the world. And whether you catch this 330-floor high rocket with a chopstick, they're improving on knowledge and technology. But these improvements are so dramatic that it could make humankind a spacefaring civilization. So this is still a quantum leap innovation. So there are certain improvements, continuous improvements are so amazing, so dramatic, that it could be a quantum leap movement. But a true QLI, a quantum leap innovation, occurs when there is a proper invention, like the invention that allowed humankind to fly. And this is a profound moment for humanity, that you could fly like a bird. Is it just raw power? Did we strap ourselves to a rocket engine and just fly across? No. We learned something. We learned something dramatic to be able to fly. And those are the kind of inventions that matter to us. All innovations, whether it's breakthrough innovation, disruptive, or incremental, all innovations lead to product differentiation. And this is very similar to evolution, that when we evolve, we differentiate. As a species, we become a new species. And this happens with all innovation. But a quantum leap innovation results in tremendous impact, tremendous social impact, clear economic value, including in space travel, clear economic value, and on top of it, it advances humanity. And that is a quantum leap innovation. That's what technology does. So I have a simple question. My title was why it is a quantum leap innovation for continuous flow manufacturing. But I have a simple question. Is IT, information technology, a quantum leap innovation? I'm sure all of you would agree. Yes, it is a quantum leap innovation. Look at what is happening. All of the gadgets I use today, the smartphones, the tech that is allowing you to have this projection happening is part of the IT innovation. And today, this innovation has gone so far in terms of processor stack that AI has become truly possible. 20 years ago, we didn't have the ability to deal with data. But now, the processor capability has gone so far ahead in the transistor stack that we can contemplate AI on our smartphones. And this is what IT is doing, and how it is doing through clear innovations, inventions in manufacturing, inventions in material technology. And that's how AI is made feasible. IT is allowing AI to happen because of changes in electronics. This is the backbone of quantum leap innovations. So in the 20th century, as opposed to all of the previous centuries, we had this big breakthrough moment in terms of information technology, and we got solid-state electronics. So last century was a century of information and communication technology. But what about this century? This century, we're extending information technology to make intelligent decisions, not just automation, whether it's autonomy, whether it's ability to have decisions on what documents we are working on and so forth, on communications, graphics, visuals. We can get computers to do for us. But is that all? Is that going to make the world greener, better? So I want to reintroduce something to you, which has been a big inspiration to me as a kinematician. Thank you for introducing me as an analytical kinematician. I belong to a school that started in India 2,500 years ago. I still owe my heritage to a sage called Apastampa, who was a geometer. So when I say my background to someone, I say I come from the school of Apastampa. And apart from Apastampa, there were lots of geometers in this country, going up to Aryabhatta, Brahmagupta. But a famous kinematician, all of you will know, is Archimedes, who described the simple machines. But look at this machine that the Wright brothers worked on. And this is before anyone could control a flight. They realized that to control a flight, you need three-dimensional control of the movement of the flight. And this is inspiring for me ever since I read it. Right? Wilbur Wright, one of the brothers, said, if you're looking for perfect safety, you will do well to sit on a fence and watch the birds. But if you wish to learn, you must mount a machine and become acquainted with its tricks by actual trial. And as a country, our education system is changing. It's no longer textbookish. We're becoming experiential. We are learning to get our hands dirty. Look at our space program. It is just awesome because we're willing to try. We're willing to experiment. And this will continue in our country. And this will spark a lot of amazing innovations. What did the Wright brothers do? They brought control to a flight in all 6 dimensions. The 3 dimensions which give position, and 3 dimensions that give control over the orientation, roll, pitch, and yaw with rudder control. And that's what they patented. And because of this, we can fly today. But as we take flight in this 21st century, we have to be very mindful of what India has done to the world. We have saved the world. We have to be truly proud. Since the Industrial Revolution started in 1750, nations around the world, people around the world, societies around the world have been warming up our planet, causing climate change. In the last 250 years, there's so much of carbon dioxide in the planet. And India's contribution, our country's contribution over the last 250 years is less than 3%. 1/6 of the world's population. We could have contributed 16%. We did not. Look at this graph. We contributed 3% over the last 250 years. We saved the planet Earth. And today, as a society, we can continue to do this. If you're conscious, that is the path of evolution. If you're truly conscious, like our Prime Minister wants, like our government wants, if you're truly looking at life, consumption, and what we're doing, we can truly contribute to this planet. And in this, we need technology, and it's all about climate innovation. There are lots of startups working on climate innovation. We heard about mobility, about energy, hydrogen, agriculture, and so on and so forth. We as a company have chosen to work on three major programs. Waste and energy from waste, agri-waste, bioenergy, biofuel, materials from waste, and food. Because if you want to build climate resilience, we need tough human beings. We can't have weak people. And these are the three major programs we run as a company. And to be able to do this, we have to build continuous flow technology as a breakthrough. And that's what I'm going to present in 2 minutes and allow you to follow. It's not invented by us. It's called process intensification. Continuous flow process or continuous flow manufacturing is really important for humanity. And it is going to change the way we think about manufacturing. And we apply a form of continuous flow processing, continuous flow manufacturing, and we call it intelligent compounding. And using this engine, just as internal combustion engine and integrated circuits, the other two ICs disrupted transportation, communication, we can truly transform the world around us. And that's our attempt. And like I was introduced, we have 150 plus patents on this technology. But the moment I mention continuous flow manufacturing, you will think of automotive and discrete manufacturing. And that is correct. Because the Toyota way, if you think about it, would say that create a continuous process flow like an assembly line and take control over your process. But it was possible in discrete manufacturing like components and automotive, but really not possible in process industry. And that is where technology had to be created. But this is a beautiful slide that covers how innovation and continuous improvement happens all the way through control over flow and building a culture of learning. If we have continuous flow manufacturing and intelligent compounding, we can truly disrupt the world. What Steer is doing using this application is to take plastic waste and make hard wood substitute, a material that can actually have the strength, durability, and toughness that rival teak wood and rosewood. And therefore, we don't have to knock down forests. This is technology. This is continuous manufacturing. We're working on soil. Because if we have to keep our soil safe, we need to cover it from losing water, losing the nutrients, and to protect crops. And Again, intelligent compounding, continuous flow manufacturing creates this possibility, resulting in possibly billions of dollars of opportunity. And in terms of food and pharmaceuticals, I want to summarize. This session is about emerging technology. I wanted to tell you, beyond digital, mobility, energy, one should please lay focus on manufacturing technology and materials technology. Number one. Number two, make innovation an institutional concept in your organizations. And that involves 4 layers. You need to have people who understand models, how things are working, what are the relationships. Today, not just natural sciences, even social sciences, politics became political science, economics, sociology, psychology, everything is considered as science. Why? We create models with it. So have scientific mindedness in your team. Have the ability to create newer tools. Be having tech people, technologists in your team. And of course, every team, when it has a plan and can improve on the plan, that's when it grows. So obviously, having people who can deliver, execute becomes important. As an organization, we have maintained a level of being unknown. If I ask you, before I came on this stage, how many people have ever heard of Steer or Babu Padmanabhan, I'm sure none of you will raise your hands. And there was a design to it. For years, we worked and still work very quietly, because I believe innovation and true inventions happen when you can protect yourself from too much of noise. Isolation helps in creating breakthroughs. And these are my mantra, because if you can't isolate from the shallow-minded, insulate from the short-sighted, be immune to unsolicited criticism, we cannot make breakthrough. But that is not enough. We have to put ourselves to the spot, stress, and nourish. And that is why these kinds of forums are important. We create accelerators. We work on taking our incubated products into the market. So I'm here to talk to people who are interested in food startups, interested in material startups, and bring them on our platform. All right, so that's my talk. We believe that India can be a force in not just meeting climate goals, but also making sure the world can see sustainable development. Thank you very much.